At the top of group 2, what is it?
Beryllium.
Beryllium. Okay, and then group 17, period 3 is chlorine. Chlorine.
Mine's the first one.
Hydrogen is the first one. No, not hydrogen. Hydrogen and helium are in the first period, then fluorine, then bromine. So even though the first period only contains hydrogen and helium, it still counts as period 1, period 2, period 3, all the way down. Okay? So group 17 is the halogens. Okay, I shouldn't have said that because we're going to talk about that later. But group 17 is the second to last one over there, and then period 3 is 1, 2, 3 into chlorine. Okay? So the first thing we need to review with the periodic table is that groups go which way? Up and down or left to right? They go up and down. Groups go up and down. Okay? And something that you need to know is that the groups are labeled 1 through 18. Okay? And I think on your periodic table they might even be labeled for you. Is that right? They are. Okay. So I like to label them 1 through 8. Does anyone remember why that might be? I kind of talked about it in the Chem 1 a little bit, but you don't have to do this part yet. I want to just talk about the periodic table, so leave that up, okay? You can get your regular notes out if you want. We're going to be taking some notes along with the periodic table, but I like to label the periodic table 1 through 8 instead of 1 through 18. And the reason I like to do that is because there is a pattern that follows that. Okay? And I'll show you how I like to label them.
Wait, I think I did it wrong. I know I did it wrong.
I like to label 1, 2. I skip this in the middle and go over here 3, 4, 5, 6, 7, and 8. Okay? The reason I like to do that is because there is a certain chemical property that matches these numbers with the groups. Does anyone remember what that is? Valence electrons. Good. Okay? So what is happening here, and the reason I like to label it that way is because group 1, all of these elements here have 1 valence electron. Okay? When you see we abbreviate it VE like that, that means valence electron. Okay, so let's review a little bit further than that. What does a valence electron mean? Good. Valence electrons are outermost electrons. That's what a valence electron is. It's the outermost electrons. They're in the outer shell. And the reason they're important, can anyone tell me why are valence electrons more important than inner shell electrons? They determine their reactivity, right? They tell us how reactive they are. But even simpler than that, what do? What are they available to do? Bond, right? They're available to bond. So valence electrons are the outermost electrons that are available to bond on an atom. Okay, so that's important what they are. And then we can look at the periodic table and we can know how many valence electrons an element has based on its group number. But it doesn't work for this middle section of the periodic table. Okay, so while your periodic table calls this group 13, 14, 15, 16, 17, 18, like that's fine, but I like to keep them at 3, 4, 5, through 8, because that way I can trigger the valence electron number, right? I know the valence electron number. So what I'm saying is the way you number them doesn't really make a difference. So you either have to know that group 3 or 13 has 3 valence electrons, 4 or 14 has 4, 5, whatever, okay? Does that make sense? Okay. I want you to also look at the back of your periodic table, and I have an ions sheet. Okay? What does it mean for something to be an ion? It has to have a charge, right? And ions have a charge. And so this periodic table of ions, if you haven't taken Chem with me before, have you seen this sheet? Did you guys get something like this when you were in Chem?
I don't think I got one of those.
Sorry, Rory, you might have been on that. Okay, this is the periodic table of ions, and what it tells us is that it tells us each element's most common charge, right? Most common charge. All right, so I want you to start looking at the groups and seeing the relationships between their charges. Do we see any patterns within the groups about charges? Yeah, what's group 1's charge?
+1.
+1. Group's 2's charge is plus 2, right? So we see plus 1, plus 2. Oh, no, I could write it too. Okay. Plus 1, plus 2. In the transition metals, is there a pattern? Not so much. Sorry, transition metals are these guys right in the middle. Not so much of a pattern, right? They're all over the place. When we get over to here, what do we see our pattern is? Plus 3. With carbon, we don't see really a pattern there, but these guys are plus or minus 4. They can go either direction. Okay? Then when we get to nitrogen, we go minus 3, minus 2, minus 1. And then we don't see any charge for these group 18 elements. Why would we not see a charge on group 18? They have a full octet, right? Have you heard that word before, octet? When I say octet, that means we have 8 outer shell electrons, okay? Or 8 outer shell electrons, or a full shell, right? If I say they fulfilled their octet, that means they have a full shell. So these guys in group 18 have a full shell. Okay, so now I want to talk a little bit about where these charges come from. How are these charges brought about? How do we know what an element's most likely charge is? Okay, so let's look at group 1. We know that group 1 always has 1 valence electron. So group 1 has 1 valence electron. Okay, agreed? So if I look at an element in group 1, let's say I look at lithium. Lithium has 2 electrons in its inner shell and then 1 electron in its outer shell. So lithium wants a full shell, which means, is it going to be easier for them to gather 7 to fill that outer shell, or is it going to be easier for them to give away 1? Give away 1. So if they give away their 1, that leaves them with 1 less electron than they were intended. So if they're down an electron, what does that mean their charge is going to be left with? If they've got 3 protons and now only 2 electrons, what's their charge? Plus 1. Is that lithium's charge on the periodic table? Yes. And is that the charge for all the rest of the group 1 elements? Yes. So that's where the charges come from. Group 2 has 2 valence electrons, so is it going to be easier for them to give away 2 or to gather 6? Give away 2, right? Same here with the 3s. This group, it gets a little bit tricky because they have 4. So is it easier to give away 4 or take in 4? Well, it doesn't really matter. It's the same either way. So it's dependent upon what it needs to bond with. Okay? Uh-huh.
So when boron and carbon, if they don't have like the charge,
Yeah, so it can bond with whatever we need it to. Boron doesn't have a charge because it's one of the exceptions in that it's okay if it doesn't have a full octet, which why it doesn't have a for sure assigned charge. But it has 3 electrons, right, in its outer shell. But in here, carbon and silicon aren't exactly assigned charges because they can go as an anion or a cation. Right? They can behave either way. -3 in this section. These elements have 5 valence electrons. So what do they want to do? Give away 5 or bring in 3? They want to bring in 3. So if they take on 3 extra electrons, that leaves them with a -3 charge. Right? It's a little counterintuitive to think about extra electrons being a negative, but that's how it works. Okay? Same here with this, same here with this. So any questions about how those charges came about? Okay. Good.
For sure.
Good. The bless you. Metal set to the left of what we call the stair step. And the stair step's not on your periodic table, so if you want to include that on your periodic table, I would recommend that you do that. The stair step goes like this. Okay, so I would go ahead and draw that stair step on there just to give you kind of a clear, definitive line. This is what it would look like if you had to give a clear yes or no on metals or nonmetals. Okay? So in general, metals are to the left of the stair step. There's one exception to that. What is it? Hydrogen is the exception. Hydrogen sits over here because it has one valence electron, but it's not a metal. Right? It's a non-metal. One exception to that. Okay, so metals sit to the left. Non-metals sit to the right. I want to go over a few characteristics of metals. And so I want you to kind of write these characteristics down. We're going to see what we can come up with as a class in terms of characteristics of metals. Okay, anyone have an idea? What are some characteristics of metals or properties of metals? What did you say? They conduct electricity. Good. They conduct electricity and what else?
Heat.
Yeah, electricity and heat. And when we say they conduct those things, what's that mean? They carry them. It travels through them well, right? That's what the conductivity means. It travels through them. The reason it travels through metals well is because the way that metals bond allows for what we call delocalized electrons, and that means electrons can roam, and it can carry that heat and electricity. All right, what are some other properties of metals? Okay, shiny we know. What does the word ductile mean? Good, you can pull it into a wire. Ductile means you can pull it into a thin wire. What's our best metallic example of that? Copper is a good one. Right? Silver is a good one. I don't know, there's lots of other ones we can think about, but those are two big examples for ductility. Ductile means we can pull it into a wire. There's another one that means we can pound it into a sheet or we can kind of mold it. What's that? Malleable. Good.
It's like
malleability.
Mallard.
Yes, that's true. You could think of it as, yeah, that would be good word association. All right, malleable means we can bend it into anything we need to. We can pound it into a sheet. So what are good examples of that? What are good metals that we put into sheets? Aluminum. What else? Gold. Tin. Right, all of those are good examples of that. High tensile strength was another one we heard. High tensile strength means basically they're tough. It's not going to shatter upon impact, right? It's kind of the opposite of brittle, right? It's not going to shatter. Last thing I want to talk about with metals is what state of matter are they usually in?
Solids.
They're usually solid at room temp. Okay. What's our one exception for that? Mercury. Right? Mercury is an exception of that. Good. Okay, so those are basic concepts of metals. I hope this should all be a review for everyone. But now if we look at non-metals, they sit to the right of the stair step. So I need to redraw my stair step here. They sit to the right of the stair step. Okay. Non-metals have what basic properties? What do you think? How do you think they're going to behave? They're gases at room temp, mostly, not all, but most, right? Carbon's not a gas at room temp. Sulfur, they're not a gas at room temp, but a lot of them are. Good. They're not good conductors of heat and electricity. Okay, I wrote not good. I could just write bad. Bad conductors of heat and electricity. Okay, why is that good for us? Why is it good for us that they're not good conductors of electricity and heat?
Most of the time it's in a gas state, so you can't control the...
Okay, yeah, good point. You wouldn't be able to control it. What else? Why are we as humans glad that
We don't get like
We have like oxygen in us.
That's right. We breathe these things in. So if heat and electricity are traveling through that, like that's not good for us. Okay, so that's why. I think that's fine for nonmetals. I don't think of any other major properties we need to look at. They have a little bit more variability in their properties because you have some that are metals, some that are nonmetals, some that are liquids. Some that are solids, gases, and liquids at room temp. They have a little bit more variability, but that's what we basically need to know. Last group is metalloids. Metalloids sit right along the stair step. So if you want to outline these on your periodic table, you are welcome to do so, but you don't have to necessarily. They sit right along the stair step. So these include, right here's our stair step, and then I'll kind of shade them in here if I can do them off the top of my head. Boron, germanium, arsenic.
Looks like spray paint.
I think those are the ones. Boron might be. I need to know that off the top of my head, but I don't know all the time. Yeah, okay. Alright, so those are your metalloids. Astatine is not listed as a metalloid. It looks like it's listed as a group 17, so. But what do we think metalloids have in terms of properties? What are some of their properties? Yeah, they have characteristics of both. Okay, they have characteristics of both metals and nonmetals. That's really all I need you to know about that, right? These guys right here, I know it's kind of hard to see. Some of them are solids. Actually, all of them are solids at room temp. Some of them are really brittle. Some of them are shiny. Some are not, right? They just behave in that way, right? Some of them look like metals. Some of them don't. The only thing that you need to know extra about that is that they are called semiconductors. They're called semiconductors of heat and electricity, which means it's possible. They're maybe not the best at it or the most efficient at it, but it's possible. Okay? Questions with that? Those are our main three sections of the periodic table. I hope and I believe that's all review for you guys. All right, this one I need you to contribute here. You're going to drag these little flags to where it tells you to.
Oh God.
The halogens are group number what? 7 or 17, right? This is the halogens. Okay? Group, the alkali metals, which number? Group 1, alkali. Okay, the noble gases, 8. Good, that's one we should have probably gotten. Noble gases, and then the last one is alkaline earth metals. That was a little tricky between group 1 and group 2 because they're pretty similar. The alkaline earth. Okay? We're going to go over basic properties of each of these groups just really quickly. Let's start with the alkali metals. These are group 1. All right, the alkali metals have 1 valence electron. That means they are super, super reactive. Okay, very reactive. Okay, they're actually too reactive to be found in nature. They're too reactive to be found in nature. Okay, that's because of their 1 valence electron. Okay? So that means we don't ever see chunks of sodium metal or potassium metal or anything like that floating around, right? They're too reactive to be found in nature. So what are some things that we need? What are some things that our bodies need from group 1? Potassium. And what else? So yeah, we need hydrogen, we need sodium, we need all of those things. So how can our body get those things if we're not eating sodium metal? We're not inhaling potassium metal. Okay, yes, bananas, but is there chunks of metal in your bananas? No. Right? So that means potassium and sodium and all these things that we need have to be in a compound. They're bonded with something else. We eat that compound or we eat whatever it is, and our body extracts that thing out. Okay, so they're too reactive to be found in nature. They react especially with water. Do you know what group 1 metals do with water? They go boom? Yep. Okay, remind me later and we can watch a video of the group 1 metals reacting.
I think we should do it too.
No.
I say we start with francium.
No.
You could do it with like a really small piece.
No. I don't even think we have group 1 metals here. Metals. Okay, they can be cut with basically a butter knife, and they're very silvery in appearance. Okay, but they're very soft. It really looks like the consistency of like a stick of butter when you cut it. So. All right, group 2, the alkaline earth metals. Not much difference here between group 1. Okay, so you can just put similar to group 1, but they have 2 valence electrons. They have 2 valence electrons. They're still too reactive to be found in nature. Sorry, my handwriting is really not good today. I could slow down a minute. Okay. Similar to group 1, they are a little bit more what we consider traditional metals. They behave a little bit more like traditional metals than group 1. They're a little bit tougher, not as soft as group 1 metals, but they have basically the same characteristics. All right, the halogens. How many valence electrons? 7, because they're in group 7 or 17.
Yes.
Okay, halogens have 7 valence electrons. They're the most reactive nonmetals. Okay, so they're the most reactive group of nonmetals. Why do you think they are so reactive?
Because they just need that one.
They only need 1, right? So they'll bond with anything to get that 1 electron. Right? They'll bond with anything to get that 1 electron. These guys are a pretty unique group because there's 2 that are gases at room temp, 1 that's liquid at room temp, and 2 that are solid at room temp. So there's a little bit more variation there. Okay, any questions with halogens? Last one's noble gases. What do we know about them? They are all gases at room temp. They're generally unreactive. Right? They generally don't react with things because they have a full shell or full octet. Good. Oh, I don't know why that stuff didn't erase down there at the bottom. Okay, they generally are unreactive because they have a full shell. Okay. Last part of the periodic table I want you to look at is the group in the middle, or the section in the middle right here, and they are called the transition metals. Okay, the transition metals don't follow the same valence electron rules, but they are what we would consider very traditional metals. So think about, when you say metal, what elements come to mind? Gold, iron, silver, copper, zinc, titanium, right? All of those things are in the transition metals, right? So when you think of metals, those all kind of come to mind, and they're in the transition metals. So they're very what we consider, the main metals. They don't follow rules in terms of valence electrons. What do you notice about some of them? Turn it over to your ion side. What do you notice about a lot of the transition metals? They can have 2 different charges. So that means they're really stable. Transition metals in general are pretty unreactive, so they're very stable. And having the ability to take on 2 charges just means that they're comfortable, maybe not having a full octet, or maybe bonding with lots of different things, even though they're not super, super reactive. But they're able to bond in a couple different ways. So the ones that are listed here are the most common. They can have more or different charges if they need to be. Okay, that was our basic introduction and review of the periodic table. Any questions about groups or anything like that? We didn't really talk about periods. Periods go left to right. We very rarely refer to things in period 2, period 3, but it is important that period 1 starts here, period 2, period 3. So we'll look at that a little bit more when we get to electron configuration, but very rarely would I say period whatever to get to it. I'll always identify by group numbers. Okay? All right, your job today is to make flashcards for a group of polyatomic ions. Polyatomic ions are going to allow us to be better at naming. So polyatomic ions are a group or a compound that have a charge. Right? An ion with multiple atoms, that's what polyatomic means. So I'm going to have a list of polyatomic ions I need you to memorize. I intend for you to have a quiz over them next week. Off the top of my head, I can't remember if it's Tuesday or Wednesday, but I will look that up for you. I think there's 14 ions on this sheet. I have paper for you to make flashcards. If you don't have flashcards with you, that is fine. I have paper we can cut up to make flashcards. But you are going to need to have them. Okay, so I'll pull this up here. Let's see if I can get this.
I guess I'll get a good green thing, but
Okay. In Google Classroom, okay, I have posted here, here's our need to know polyatomic ions. I'll put it up on the board so you don't have to have yours up. But this is the notes that I usually get for Chem 1 about the periodic table, so they're a lot more detailed. If you want to open those up and read through them, you don't have to by any means, but they're there in case you missed something or want to look at it again. Here is the polyatomic ion sheet. You can pull it up on your own screen if you want, or you can just look at it up here. Should have the name on one side, formula, and the charge on the other side. You will have to know formula and the charge.
Instead of doing flashcards, could I do a Quizlet?
You could do a Quizlet if you wanted to.
Would that work?
Yeah.
Okay.
You need to have them memorized. The quiz for you guys will be